Good morning, viewers. Welcome to this video lesson. So today in our video lesson, we will be discussing about IC engines. So in this, I would like to give a overall picture of an IC engine, right from what is an IC engine, basically from starting from what is an engine, what is a heat engine, what is an IC engine, what are the advantages of IC engines, and what are the main parts in IC engines, and also what are the terminologies that we use in IC engine, and the two-stroke engines, four-stroke engines, and what are the comparison between two-stroke and four-stroke, comparison between petrol engines and diesel engines. So actually this is a big topic, but I would like to give an overall idea about this IC engines. So after viewing this video, you will get some idea. I hope that you will get a better idea about IC engines. So let's get started. And I have prepared one PowerPoint presentation. We will follow that PPT and we will go accordingly. So hereby I'm sharing the PPT that I have prepared. So we'll go with that one. So IC engines. My name is Anand Padavala. I am senior faculty member in the Department of Technical Education, Government of Telangana, and I'll take classes for diploma students of mechanical engineering branch. So this video is, this topic is not only used for diploma holders, but also for engineering students. So if you really like this video, please subscribe to my channel, and share this these videos with your friends or anyone who is in need of this topic. So IC engines. So let us start with that. Now, so let's start. What are engines or engine? I think this is a very familiar term. We'll be using this one. So what is an engine? Generally in general colloquial things are generally layman's. If at all a layman has to give a definition to an engine which will move, that is called engine. Generally we will call it as. But mechanical as a mechanical engineering students, we should give a proper definition for engines. So what is an engine? Engine is a device. An engine is a device or a machine designed to convert one form of energy into mechanical energy. So basically what an engine will do, engine is a device, and it is in this engine what happens, one form of energy, any one form of energy will be converted into mechanical energy. Thereby this mechanical energy will use it to move or to do some work. It will, that's what happens. So this is what an engine. Examples, we know automobile is an engine. So in this we will have an engine, and so we will burn petrol or diesel in this inside the engine, and it will this heat energy will be produced, and this heat energy will be converted into mechanical energy, thereby it moves. Second one is fan. Generally we won't call fan as an engine, but fan is an engine as per this definition, because what it will do, it will convert electrical energy, electrical power into mechanical energy, thereby it will rotate, thereby we will get air from it. So this is a fan. And third one is a lathe machine. Yes, lathe machine is also a machine where electrical energy is converted into rotate the head portion, headstock, the spindle which is attached to the headstock. Thereby it will rotate, and a job will be attached to the spindle, and there we will go for turning operations. So all these things, one form of energy has been transferred to mechanical energy. That's why all these things are called engines. So engine basically a device or a machine which is designed to convert one form of energy into another energy, specifically into mechanical energy. Heat engines. So engines are many different types, out of which heat engine is a one type of engine. So what does it do? A heat engine is a device which transforms the chemical energy of a fuel into heat or thermal energy and uses this energy to produce mechanical work or useful work. So when we defined engine, what we said, one form of energy converted into mechanical energy. But specifically here, heat engine means it will convert heat energy into mechanical energy or thermal energy into mechanical energy or useful energy. Such type of engines are called heat engines. Where do these heat come? Definitely by burning some fuel, whether it may be a coal, petrol, diesel, whatever it may be, gas, whatever it may be. And by burning this, by burning, the chemical energy of the fuel is converted into thermal energy or heat energy, and this heat energy will be converted into mechanical energy or useful work. So so heat engine is a device which transforms chemical energy of a fuel into heat or thermal energy and uses this heat energy to produce mechanical work or useful work. So everyday examples of heat engines include thermal power stations, in which what we will do, we will burn the coal. So there burning of coal will be done in the boiler, and in this boiler here water is converted into steam, high pressure high temperature steam, and these high pressure high temperature steam will send, that means heat energy will be sent into the steam turbine. So this steam turbine, it will, this high power, high temperature, high pressure, high temperature steam will rotate the blades of the steam turbine. Thereby, you will get mechanical energy. And this to the steam turbine, the electric generator will be connected. So thereby, we will get a power. Electricity will be produced. So that's what happens thermal power station. So this is a good example of heat engine. Automotive, automobile vehicle, a bus, car, or anything you take, trucks. This is what happens. Heat energy, that fuel energy, chemical energy of a fuel will be converted into heat energy by burning that fuel inside the cylinder, and thereby this heat will be converted into mechanical energy, and this mechanical energy by rotating the crankshaft will be made available to move the wheels. So this is what happens in automobile. And also steam locomotives. As I said, steam locomotives are the best examples for heat engines. Though this here, coal will be burned here or with the help of anything. So that steam will come, and this steam locomotive will run all the bogies which are attached to this one. So these are the examples of heat engine. Now, what are the various types of heat engines? We will see. So heat engines are broadly classified into two categories. One is external combustion engine, second one is internal combustion engine. So based on where the combustion takes place, heat engines means we need to have some fuel. Fuel has to be burned. So where we are burning or where the combustion process is taken place, whether it is external to the engine or inside the engine. If it is external to the engine, it is called external combustion engine. If it is inside the engine, it will be called internal combustion. Therefore, IC engine means internal combustion engine. Internal combustion engine is a heat engine where the combustion of fuel will take place inside the cylinder. Now, external combustion engines, if you take the heat energy, where simply we should say that external combustion engine means the combustion process will take place outside the engine, not within the engine. That is what an external combustion engine. So examples are in steam engine or steam turbine plant. As I said, just by giving examples of heat engine, the heat of the combustion is employed to generate steam, which is used to in a piston engine or a turbine for useful work. In steam engines or steam turbine plants, this steam will be produced mechanical work. But where the steam will come? By combustion of the fuel outside the steam turbine, that is at the inside the boiler. There we will get the water will be converted into high pressure and high temperature steam. This is what the example. And also in closed cycle gas turbine also, the heat of combustion in external furnace is transferred to gas usually. air which is used. So one more example is gas turbine. Gas turbine also we will use external combustion process. Now we'll come to the our discussion is internal combustion engine. IC engine means internal combustion engine. As I said, internal combustion engine in an internal combustion engine, the ignition and the combustion of the fuel occurs within the engine itself. So both ignition and combustion will take place inside the cylinder. And whatever the energy that we get because of this burning, that means thermal energy or heat energy will be produced. Some part of this heat energy will be used to do some part. So that is what happens. So internal combustion means the combustion takes place inside the cylinder. So we have so many examples. You have gasoline engines, uh, diesel engines, gas turbine engines, rocket propulsion system. All these things use internal combustion. So what are the major advantages of IC engines over external combustions? So what really, why we need IC engines? What are the advantages that we have when compared to the external combustion engine? So more compact and occupies less space. If you observe external combustion engine in the thermal power plant, the boiler setup, it will take a lots of space. So the internal combustion is compact and less space. So that is the main advantage. Starting of an IC engine is very easy and quick. In order to start a steam locomotive, we have to start at a very early before the schedule of the train. So the starting of IC engine is very easy and quick, possessing high thermal efficiency. The thermal efficiency of an IC engine is very high when compared to the external combustion engine, because there will be a lot of wastage will be there. The heat which is produced outside the engine will be rejected to atmosphere, most of that. So here also rejection will be there, but the amount of heat rejected will be less when compared to the external combustion. Therefore, thereby we will get higher thermal efficiency, simple in design and low initial cost, of course, and the mass of engine per unit power output is low. So if you take the weight per unit output, if we take, and the mass of the engine is low, that means the output that we are getting in IC engines in terms of per unit of mass, if we take, the output will be more, and the mass, if you take, mass will be very less in the case of IC engine. That's why it is more compact and easy to design and construct. These are the advantages that we have with IC engines. Now we will classify IC engines. So IC engines can be classified into many ways. So under different criteria, we can classify IC engines. So let us go through various criteria, and thereby we will classify according to that criteria. So first one, according to the type of fuel we use. So what are the type of fuel we use? Based on that, it can be classified into petrol engines, diesel engines, and gas engines. So if we use petrol or high volatile engines, they are called petrol engines. If we use diesel, then it is called diesel engine. If we use some gasoline gases, then it is called gas engines and all this. LPG, all these gases are there. According to the working cycle, that means in every engine there should be a working cycle, and these working cycles, based on which working cycle it operates, based on that it can be classified into two ways. So many ways are there, but majority: auto cycle, diesel cycle, and dual combustion cycle. Auto cycle and diesel cycle, these names of the cycles are given after the inventors. That means those are invented, Rudolf Diesel and Otto. All these are, they have invented, therefore the cycle. So accordingly we can classify as auto cycle, diesel cycle, or dual combustion cycle. According to the number of strokes, we often hear the 2-stroke engine or a 4-stroke engine. Based on that, so number of strokes that are there, that means if we have to complete one operating cycle, if you have 4 different strokes are there, then we will call it as a 4-stroke engine. Or to run one operating cycle, if we have only 2 different strokes, then we will call it as a 2-stroke. So according to the number of strokes required. According to the method of ignition, that means fuel has to be burned. How we are burning the fuel? So based on that, this method of ignition, we will be classified into two engines, SI engine and CI engine. SI engine means spark ignition and CI engine means compression ignition. So spark ignition means where spark plug will be provided. Generally, we will use in petrol engines. A spark will be ignited. The spark plug will ignite or burn the fuel with the help of a small spark produced by the spark plug, and this spark will burn the fuel air mixture inside the cylinder. That is a spark ignition. Generally, this is used or employed in petrol engines or gasoline engines. Compression ignition means where compressed air within the air is compressed to a major extent, and this compression, after the compression, the air will come very hot and high pressure. Within that, into that high pressure and high temperature air, fuel will be injected. So this fuel will be ignited itself because of this high compression, compressed air. So high compressed air itself will act as an ignition. That's why it is called compression ignition. So generally this is used in diesel engines. So according to the number of cylinders, generally we will have bikes and all these things will have a single cylinder. Of course, some bikes, two-wheelers have two cylinders also. So number of cylinders. So we have single cylinder engines or multi-cylinder engines based on that. Cars and cars, buses and all these things are multi-cylinders. Generally, you have a small car, you have four-cylinder engine. According to the method of cooling, the cooling is very necessary because it will produce a lot of heat. So the engine has to be cooled. So in order to have, we have two types of cooling methods. One is air cooled and second one is water cooled. Air cooled means direct, the engine is subjected to the atmospheric air. So thereby the temperature, the engine will be cooled with the help of that atmospheric air only. So mostly all the bikes, two-wheelers are air cooled ones. Water cooler means this engine is circulated through a water channel. So the water will take away the whatever the unnecessary heat is there. So that's what. So water cooled four-wheelers, all four-wheelers and above are water cooled engines. According to the method of governing is very important to balance the system. So quality governed engines, quantity governed engines, hit and miss governed engines. So all these things are according to the method of charging, how we charge. Sometimes we need extra charge. So they are called supercharged engines, and normal charging is natural aspirated engines or supercharged. So according to the arrangement of the cylinders, in multiple cylinders, you have, even in single cylinder also, you have how the cylinder is arranged. Based on that, we can categorize it horizontal cylinder, vertical cylinder, V-shaped engine cylinder, or inline, that there will be in same line, all the cylinders will be, or radial, around a circle, if all the engines are provided. So based on that, we can categorize into these ways. For example, if you take a single cylinder engine, these Hero Honda or Hero motor vehicles, all will be of horizontal cylinders. And if you take Bajaj, all Bajaj will be of vertical cylinders. Based on the position, how the cylinder is, that will be classified. According to the speed of the engine, we have low speed engines, medium speed engines, and high speed engines, based on the maximum speed that an engine can perform. According to the applications, so where we will use for stationary purposes, or for marine, in marine engines, or for locomotives, or aircrafts, or automotive. So based on that, we can classify these things. So according to the application, we can classify, and according to the basic engine design, that means whether it is a reciprocating engine or a rotary engine. Based on that, we can classify. So these are the classifications of broad classifications of IC. There are many other methods also, other classifications also. These are the major classifications according to the different criteria. So according to which. So we will take up a reciprocating engine, main parts, components of a reciprocating engine. So I'll show the picture. Just I'll go through what are the basic components of an IC engine. So basically, you should have a cylinder. The first important component is cylinder. This is a heart and soul of an IC engine. So combustion will take place inside the cylinder. That's why this is also called a combustion chamber or a cylinder, where the actual, this is a heart. Without cylinder, you don't have any IC engine. So cylinder is the main part, important part. This is the cylinder. This is the cylinder or combustion chamber where you will have the burning of the fuel gases, burning of the fuel will be taken place. And cylinder head, above the cylinder, you will have a cylinder head. And these to the cylinder head, you will have some other parts are attached. For example, inlet manifold and outlet manifold, exhaust manifold, inlet valve and exhaust valve, spark plug in case of SI engines and fuel injector in case of CA engines. All these things were arranged or bolted to the cylinder head. So cylinder, above the cylinder you have a cylinder head, and to the cylinder head all the other parts, most of the parts are arranged. Piston. So this is a piston which will this piston movement will convert into rotary motion. So this is a to and fro motion it will give. This is a piston. And in order to give airtight inside the cylinder, the piston, the upper portion of the piston is grooved into some sort of rings. So the piston rings are provided that the leak proof. That means whatever the gases are there inside the cylinders will not come out, or whatever the fuel is there, it will not leak into this crank casing, or it will not damage the crank. So piston rings are very important. So these are the piston rings. Connecting rod. If you take, this is a connecting rod. Connecting rod will connect piston and crank. So connecting rod, as the name indicates, connecting rod. And crank. This crank will be there. And the connecting rod will connect between a piston and a crank. So crank will rotate, and this reciprocating motion of the piston will be converted into rotary motion with the help of connecting rod. And this connecting rod is connected to the crankshaft. Crank is connected to the crankshaft. Thereby, this crankshaft will be rotated, and the motion of this crankshaft will be carried to the wheels, up to the wheels of an automobile or any IC engine. That's what it happens. So inlet manifold, you have an inlet manifold. Inlet manifold means the fuel will be supplied, fuel or air will be supplied, or fuel air mixture will be supplied into the cylinder with the help of inlet manifold. And inlet manifold is provided with a valve, inlet valve. And this valve will open and close based on the cam mechanism, and this cam is connected to the crank shaft itself. This is what we have. And exhaust manifold will take away the burnt gases or flue gases out of the cylinder. This is the exhaust manifold, and it is controlled by an exhaust valve. Exhaust valve is fitted to the exhaust manifold. So this the opening and closing of the exhaust valve will be operated by cam mechanism, and it is this cam mechanism is connected to the crankshaft. And you have here it is shown as spark plug, but you, in case of petrol engines or SI engines, spark ignition engine, you have a spark plug here. Otherwise, if it is a diesel engine, you will have a fuel injector. So based on that, it will be there. So these are the main components of a reciprocating engine. Now we will see what are the terminologies that use in an IC engine. What are the various terminologies that use in IC engine? So we have here cylinder bore. It is indicated with capital D. The nominal inner diameter of the working cylinder is called as cylinder bore. So here you have a cylinder. What is the diameter? Inside diameter of the cylinder is called cylinder bore or inner diameter of cylinder. Piston area, that means the area, the cross-sectional area of the piston, that is diameter, equal to the diameter of the cylinder bore. The how much area it is there, that is called piston area. It is indicated with capital A. Stroke length. Stroke length ante nominal distance between the nominal distance through which a working piston moves between two successive reversals of the direction of motion. See, piston will move up, and after some point it will go down, and after some point it will go up at some position. So where it is going to reverse, this position to this position, the distance between these two positions are called stroke. And if the topmost position is called top dead center, bottommost position is called bottom dead center. So the distance, linear distance between top dead center and bottom dead center, or bottom dead center to top dead center, it is called stroke length. Length of the stroke or stroke. The movement from one dead center to the other side center is called stroke, and its length of the stroke is indicated with L. And dead center, as I said, dead center, the position of the working piston and moving parts which are mechanically connected to the movement when the direction of the piston motion is reversed. That means piston maximum position and minimum position. So where it reaches and it comes back, that position is called dead center. And here, after coming down, when it starts reverse and go back, that position is called one more dead center. So you have two dead centers. One is a bottom dead center. That is other one is top dead. Bottom dead center means the position which is nearer to the crankshaft is called bottom dead center, and topmost, far away from the farthest point from the crankshaft is called top dead center. For horizontal engines, you don't have top and bottom. The piston is moved from left to right. So you have a different terminology there, that is called inner dead center and outer dead center. Inner dead center means nearest position to the crankshaft. Outer dead center means farthest position from the crankshaft. So this is called inner dead center and outer dead center in case of horizontal engines, and top dead center and bottom dead center in case of vertical engines. Generally, we use TDC and BDC to represent top dead center and bottom dead center respectively. And we have a displacement volume or a swept volume. This is indicated with V suffixes, capital V suffix with, though the nominal volume generated by working piston when traveling from one dead center to the another one. So the volume which is there inside the cylinder, that means when we take inside, what is the volume that will be taken, is called swept volume. So swept volume, the formula is given as Vs equal to area into length. So cross-sectional area of the piston and the length of the stroke L. So A into L, because it's a cylinder, so AL we will get the volume. So A into L is the swept volume, or we will call it as a displacement volume or a swept volume. And one where we have clearance volume. So if you take, there will be a space between top dead center and there will be a space above the top dead center. So this is given, this clearance is given to burn the combustion. So this combustion process to take place, or to give a spark or to inject fuel, we need to have some space. That space is called a clearance volume. So clearance, see here in this one, this is a top center and the bottom dead center. This is a stroke, and above the top dead center you have some space. That space is called clearance volume. And cylinder volume or total volume of the cylinder is nothing but swept volume plus clearance volume. Therefore, V equal to Vs plus Vc. And there is one more terminology generally we use in IC engines is compression ratio. What do you mean by compression ratio? The ratio of maximum volume to the minimum volume of the cylinder is called compression ratio. So maximum volume means total volume, that is V, by Vc is the smallest volume, that is clearance volume. Therefore, compression ratio R equal to V by Vc. The more the compression ratio, more efficient the engine is. Therefore, higher compression ratio leads to higher thermal efficiencies, but you will have a difficult in getting higher compression ratios. So these are the various terminologies that we use in IC. Now we will quickly go through the functions. Working of a 4-stroke engine and also working of 2-stroke engine. When we are discussing about 4-stroke engine, I will take up both petrol engines and diesel engines simultaneously, so that you will get an idea and you will get the differences also very clear. So what are the 4-stroke engines? A 4-stroke engine is an internal combustion engine that utilizes 4 distinct piston strokes to complete one operating cycle. So to complete one operating cycle, you will have 4 distinct piston strokes. Then it is called 4-stroke engine. So basically it is an IC engine, and all these 4 strokes are given here. Intake or suction stroke, compression stroke, expansion stroke, or power stroke, or combustion stroke, any name we can call it as the exhaust stroke. So in 4-stroke engine, whether it is a petrol or diesel, you have 4 strokes. One is an intake stroke or a suction stroke, compression stroke, expansion or power or combustion stroke, and exhaust. All these 4 things happen in a 4-stroke engine. So the piston makes 2 complete passes into the cylinder to complete one operating. That means what will do? Piston, the piston 1 pass and 2 pass. That means 4 strokes it will take, and the crank will rotate 2 times. That means for 1 crank revolution, that is 360 degrees, you have 2 strokes. So for 4 strokes, the crank has to be rotated 2 times. That is 360 plus 360. It is 720 degrees of a crankshaft. There will be only 1 power stroke. For out of 4 strokes, you have only 1 power stroke. That means for every 2 revolutions of crankshaft, only 1 power stroke will be there. That means power will be generated even only in that stroke. So out of 4 strokes, only 1 power stroke will be developed. So 4-stroke engine is the most common type of small engine. So generally we will use for small engines and all these things, and also big engines also sometimes. So what are these 4 strokes that I will explain one by one. And while explaining these strokes, simultaneously I will explain in case of petrol engine and what happens in case of diesel engine, what happens. So in intake stroke, or this is also called suction stroke. As we have seen the main parts of these things. In case of petrol engine, 1 difference will be there, and in case of diesel engine, only is here for petrol engine you will have a spark plug. For diesel engine you will have a fuel injector. That is the difference. And also intake stroke. First I will explain intake stroke of a petrol engine. What happens in the intake stroke of petrol engine? So air fuel mixer will be there. Where you will get this air fuel mixer? So from petrol tank you will have a petrol, and from atmospheric air you will have a air. These 2 things will mix in a carburetor. That's why petrol engine will have carburetor. Diesel engines will not have carburetor. In that carburetor you will have air and fuel will mix it according to some ratio where it is works properly, and these at air fuel mixture will be atomized and it will be sent into the cylinder. So in this 4-stroke engine, first stroke, intake stroke, what happens? Stroke means the movement of piston from one dead center to the other dead center. In intake stroke, the piston moves from top dead center to the bottom dead center. This is the top dead center to the bottom. What happens when the piston moves from top dead center to bottom dead center? Inside the cylinder, some vacuum will be created. When vacuum is created, then inlet valve opens. Here, according to the cam mechanism, in the intake stroke, at the beginning of the intake stroke, the crankshaft will operate in such a way that cam mechanism is operated in such a way that the inlet valve opens. So in intake stroke, exhaust valve will be closed, inlet valve or intake valve will be opened, and because of the vacuum inside, the fuel air mixture from the carburetor will directly enter. This is what happens in inlet stroke. This is for petrol engine. For diesel engines, during the intake stroke, diesel air mixer will not come. Only air will come, a clean, pure air, which is filtered. It will take the air from atmosphere, and this will be cleaned with the help of filters. And the clean pure air will enter into the piston enter into the cylinder when piston moves from top dead center to bottom dead center. So the major difference is in petrol engines, fuel air mixer will come inside, and for diesel engines, only air will get inside during this stroke. This is called intake stroke. Second stroke is called compression stroke. During compression stroke, the piston moves from bottom dead center to top dead center. So second stroke. The first one is intake stroke, top dead center to bottom dead center. Second one is compression stroke, from bottom dead center to the top dead center. During this journey from bottom dead center to the top dead center, from BDC to PDC, both inlet valve and exhaust valve will be closed during this stroke. During this stroke, both inlet valve and exhaust will remain closed, and the piston moves from bottom dead center to the top dead center. And what happens during this stroke? Whatever the in case of petrol engine, the fuel air mixture which is already drawn during suction stroke will be compressed. And in case of diesel engine, whatever the air is drawn during the suction stroke will be compressed. So whatever whether it is air or air fuel mixture which is inside the cylinder will be compressed during this stroke. And this compression is for diesel engines almost 1/8 of the portion it will be compressed. For petrol engine is 1/8 portion. The compression ratio is around 6 to 10, and for diesel engines the compression ratio is around 14 to 20. The compression ratio will be there. So this is how it will be compressed. Now next one is expansion stroke. At the end of compression stroke, what happens for petrol engines? At the end of compression stroke, a small spark will be ignited by the spark plug. And the spark plug, what happens because of the spark? The high compressed, high pressure, high temperature fuel air mixture, by receiving the spark, it will burn. That's what happens for the petrol engine. For diesel engines, the compressed air will be there. High pressure, high temperature compressed air will be there. Into that compressed air, the diesel fuel will be injected into that hot compressed air with the help of fuel injector and in the form of fine spray. And that high temperature of this compressed air is sufficient to burn the fuel which is injected into the cylinder. So that's what happens in diesel cycle. So in petrol engine, you have a spark plug, it will be ignited. In diesel engine, fuel injector will inject the fuel into the hot air and it will burn. So combustion will take place at the end of the compression stroke. And due to this combustion, high temperature and high pressure and high energy will be produced. This energy and thermal energy, that means fuel, chemical energy of fuel is converted into thermal energy. High temperature and high pressure gases will be released. And this, because of the high thermal energy, temperature, heat energy, this will make a thrust on the piston here. It will produce a thrust on the piston, which makes the piston move from top dead center to the bottom. So earlier we are only moving that one. Now here the thrust is pressing down the piston. So this is the real power will be generated in this stroke. That's why the third stroke is also called power stroke. Expansion stroke because the gases will be expanded, and combustion stroke because combustion takes place and the power will be generated. That's why it is suitable to call this stroke as a power stroke. And so the TDC to BDC it will journey. The piston will move from TDC to BDC and both the valves, inlet valve and exhaust valve, will be remain in the closed position only. And the last stroke is called exhaust stroke. After the combustion of the gases inside and after the expansion, that is when the piston is moved down, then these gases are of no use. So these gases has to be sent out. So during the stroke, the piston will move from BDC to PDC, that is from bottom dead center to the top dead center. Thereby, it will send these flue gases out of this one through exhaust. So during the stroke, inlet valve will be closed, exhaust valve will be opened, and whatever the gases are there will be sent out. And it repeats. This cycle will be repeated again. Next stroke, the piston move from TDC to BDC, where inlet valve will be opened, exhaust valve will be closed, and fresh charge, whether in case of diesel engine is air comes, in case of petrol diesel engine, the fuel air mixer comes from the carburetor. So this is how it repeats. Again compression, then followed by combustion, and followed by exhaust. All these things will happen. This is what happens in 4-stroke engine. So hope you understood the functionality of 4-stroke engine. Now we'll quickly go through the 2-stroke engines. What are the various 2-stroke engines that we have? So as the name implies, the 2-stroke engine only requires 2 piston movements. That is one cycle in order to get power. That means clearly it says that in 2-stroke engine you have 2 distinct strokes will be there. Only 2 strokes in one operating cycle. So and one movement of the crankshaft, you will have 2 strokes, and within the 2 strokes only, the entire all these operations, suction, compression, expansion or power and exhaust should be operated. So 2-stroke engine is developed to obtain high power output from for a given engine size, because there out of 4 strokes only 1 power. Here out of 2 strokes 1 power stroke will be there. So where you need high powers, then these 2 strokes are very useful. This type of engine mainly used in scooters and mechanical pumping devices where the high power is required. And in 2-stroke engines, all processes, suction, compression, power and expansions are performed during 2 strokes. That is one engine, one time engine moves from up to down. That means from TDC to BDC and BDC to upward motion and downward motion. Like that. And these 2 strokes are, one is upward stroke and the second one is downward stroke. Upward stroke means in that process suction and compression will take place. Downward strokes, expansion and exhaust will take place. So 2-stroke engine. In 2-stroke engine, inlet and outlet valves will not be there. There is a major difference between 2-stroke and 4-stroke. Apart from the number of strokes, construction also is different from 4-stroke engine. There we have in 4-stroke engine, we have inlet and outlet valves here. We don't have any valves and cam mechanism here. We have only ports. Ports are nothing but holes. And these closing and opening of ports will be done by the piston itself. See here, this is the exhaust port and the inlet port, and this is only a gap. That means it's a hole, and the closing and opening will be done the piston itself. See, now it is exhaust valve is closed and inlet valve is open. When the piston moves down, inlet valve will be closed and exhaust valve will be open. And apart from these 2 things, all controlled by the piston only. And apart from these things, you have one more port called transfer port. And this transfer port will connect inside, not outside the cylinder, I mean walls of the cylinders, but within the cylinder it will be there. It will be connected between crank casing and the engine cylinder, that is combustion chamber. So it will be connected internally. So we have a 3rd port here, but in 4-stroke engine you have only 2 valves. 3rd valve will not, transfer valve will not be there. But here you have exhaust port, inlet port. Apart from that, you have a transfer port. Now 2-stroke engine. So what happens in these 2-stroke engines? We will quickly go through it. So this is what happens in the 1st stroke, that is upward stroke. Upward stroke means the piston moves from BDC to TDC, bottom dead center to the top dead center. What happens during this stroke? So when the bottom dead center, when the piston moves upward, that is from bottom dead center to the top dead center, the fuel air mixture in case of petrol engine and only air in case of diesel engine will be drawn inside. See here, this valve opening and closing will be done the piston itself. So there is no another mechanism here. No valves will be there. Only opening and closing. And this will be taken inside. That means fresh air will be fresh fuel air mixer or air will be sucked inside to the into the crankcase here. And simultaneously, when it moves up, the whatever already fuel air mixer or any air inside is there, that will be compressed. That means previous downward stroke, some through the transfer port, some might have already gone inside. That is compressed. So two things happens in this. One is intake stroke, that is the fresh fuel air mixer will come inside in case of petrol engine, and fresh air will come inside the crank casing in case of diesel engine, and simultaneously the compression will also takes place. Whatever the already there inside will be compressed. And at the end of the upward stroke, what happens in case of petrol engine, the spark will be given by the spark plug and there were burning will takes place. In case of diesel engine, a fuel will be sprayed with the help of fuel injector and combustion will takes place. And this is what happens at the end of the upward stroke. And the downstroke or downward stroke, what happens? These whatever the high pressure, high temperature gases will be inside, and this thermal energy will force the piston to push downward. That is from TDC to BDC. This is the power stroke. And after the end of the power stroke, what happens during this power stroke? See here, the exhaust port will be opened and the exhaust gases will leave. Simultaneously, this make a pressure inside the crankcase. So what happens here? Transfer port is open. So fresh air which is already drawn in the upward stroke will send to the crank casing, that is to the cylinder, inside the cylinder, that is into the combustion chamber through transfer. So it will be admitted. Two things happens. One is exhaust port will be opened, burned gases will be sent outside, and the transfer port will be opened. Therefore, fresh air will come. That means simultaneously into the combustion chamber, fresh charge will come and the burned gases will. That's why, in order not to mix these fresh air with this exhaust gases, a deflector will be provided. So it will go here, and these things will push, in fact, these exhaust gases out of the chamber. So, and it will be repeated. Next, whatever the gas already inside during this downward stroke will be compressed, and the fresh charge will become. And again, the burnt gases will go out, and the fresh charges will be sent inside the combustion chamber through the transfer port, and the inlet port, intake port will be closed. So this cycle repeats. This is what happens in the two-stroke. Then during the petrol engine, as I said, in the four-stroke engine, only petrol engine air fuel mixture will come from carburetor to the intake manifold, through intake port, and you have a combustion, and spark plug will be provided, and spark ignition will be taken place. During the compression, the diesel engine, only air will be sent inside the cylinder, inside the crank casing, and this will be compressed, and it will be ignited. I mean, fuel that only compressed, and fuel will be sent inside the cylinder through the fuel injector in the form of fine spray, and that's what. So these are the working principle of two-stroke engines, whether it is by petrol or diesel, according to that. So hope you have understood. Now we will quickly go through the differences between two-stroke and four-stroke engines. So these are the differences. The four-stroke engine, thermodynamic cycle is completed in 4 strokes of the piston or in 2 revolutions of the crankshaft. The thermodynamic cycle in 2 strokes completed in 2 strokes of the piston in 1 revolution of the crankshaft. that is within the 360 degrees of crank angle. In 4 strokes, we have a power stroke is obtained in every 2 revolutions. Here, power stroke is evaluated in each revolution. Because of this thing, turning movement is not uniform, because only in one revolution you have power, but other revolution you won't. Therefore, the turning movement is not uniform. That's why heavier flywheels are needed. Whereas here, for every revolution, you have one power stroke. That's why you need a lighter flywheels are sufficient. And power produced for same size of engine is less. In order to produce same power, the engine should be heavier, because only 1 out of 4 stroke is power. Therefore, the power produced is less for the same engine size. But in case of this one, for every one revolution, you will have a 1 power stroke. That's why you have for same size engine, the power produced will be more. Lesser cooling and lubricants are required because the lower wear and tear, because it will have sufficient time to do this. But greater cooling and lubrications are required because of high wear and tear. And the valves actuate the mechanism. Here, valves will be there. In this, in the 2-stroke engines, you won't have any valves, only ports will be there. Because of comparatively higher weight and a complicated valve mechanism, the initial cost of the engine will be more in case of 4-stroke engine. Because of the lightweight and simplicity due to the absence of valve actuating mechanism, the initial cost of the engine will be less. The volumetric efficiency is more because it will have sufficient time to draw and it will. But the volumetric efficiency is less because of the lesser time. At the same time, suction and inlet, the fresh charge will be admitted. And also, thermal efficiency is more for 4-stroke engine, because sufficient time will be there to burn. So, and also here, because some of the gases will be mixed with the fresh charge will be mixed with the exhaust and it will go. Therefore, thermal efficiency will be less in case of a 2-stroke. Applications of 4-stroke engines are cars, buses, trucks, tractors, aeroplanes. That means heavier things. So 2-stroke engine, you have scooters, mopeds, motorcycles, and hand-driven machines, and all these things will be there. For lawn cutting machines, and all these things will be there. These are the major differences between 4-stroke and 2-stroke engines. And also we will see the differences between petrol engine and diesel engine. So petrol engine follow Otto cycle and diesel engine follow dual cycle, diesel cycle. So air and petrol mixed into the carburetor before entering into the cylinder. As I said earlier, fuel is mixed with the air inside the cylinder. In the carburetor will mix, but here in the cylinder through the help of a fuel injector. Ignition is done by electric spark plug. So with the battery run spark plug will be there. Ignition is done by a hot compressed air. As I said, compression here. So here in petrol engines, a lower compression ratio because of the spark volatility of the petrol engine, petrol. And here you can achieve higher compression ratio. Petrol engines are less power output, and diesel engine have more power output due to 2 reasons. One is that diesel fuel itself have more power, and also because of the compression ratio, more time there for compression, so therefore more power will be there. Contains spark plug, it will contain in fuel injector. This burns highly volatile fuel, this burns less volatile fuel. Used in light vehicles, petrol engines are used in light vehicles, and diesel engines are used in heavy vehicles. Petrol you have a more fuel consumption, and diesel will have a less fuel consumption. Petrol engines are lighter and diesel engines are heavier. Petrol engines frequent maintenance is required, less frequently maintained is there. Of course, but maintenance cost, if you see, petrol engines have a low maintenance cost as well as less initial cost, where diesel engines have a higher maintenance cost and higher initial cost. And thermal efficiency of the petrol engine is about 26%, whereas thermal efficiency of the diesel engine is 40%. So the starting of the petrol engine is very easy due to low compression ratio, but whereas the starting of the diesel engine is a little difficult because of the higher compression ratio. And petrol engines are used in high-speed engines, and diesel engines are used in low-speed engines. But the torque developed by the diesel engine is more at high. For lower speeds, it will develop more torque. That's why for heavier vehicles we use diesel engines. So these are the basic differences between petrol engine and diesel engine. So that's what, friends. Hope you have enjoyed this thing. I have given an overall idea of IC engines. So if you really like it, please subscribe my channel, and also share these videos with your friends who are in need of these things. Thank you very much for watching this video.